So, hello everyone and welcome. My name is Alejandro Højen and I'm a member of SNOMED International's implementation support team. I want to thank you all for attending this webinar. For today's session, we have prepared an expression constraint language or ECL showcase. So for the next 90 minutes, you'll hear 5 different presentations, all focusing on this SNOMED CT specific computable language. As shown in this slide, we have the pleasure of welcoming 3 external presenters from the SNOMED CT community. So I'm pleased to welcome Sophie Williams from Barts Help in the UK, Michael Lawley and Matt Cordell from Csiro in Australia. And together with myself and my colleague Alejandro Lopez Osornio, each of us will give us short presentations, so you will end up having heard about the objective of the expression constraint language, the newest features, and a range of use cases, ideas, and experiences. So we really hope that you will enjoy the session, and at the end there will be room for time or time for questions. So you can use the Q&A feature to or the chat function to submit your questions. But firstly, I'd like to just give a little bit of background on the expression constraint language to set the scene for the other presentations. SNOMED CT is designed to be the semantic foundation of clinical information systems and provide a solid foundation for the representation of clinical data. And through its logical design and formal foundation in description logic, SNOMED CT supports computer processability and enables advanced search, retrieval, and analytics features. It uses concepts to represent clinical meanings, descriptions to represent the human-readable representation of concepts, relationships to represent concept definitions, and reference sets to represent subsets, maps, and other types of derivatives. And the expression constraint language allows us to utilize these design features to query over SNOMED CT content and selectively specify the relevant inclusion criteria. To explain what the expression constraint language does, let's first talk a bit about SNOMED CT expressions. Because as you probably already know, all SNOMED CT concepts can be represented as different types of expressions. In this slide, you see a few examples of pre-coordinated concepts and their inferred definitions represented as expressions. For example, the concept excision of left kidney, as you have it here, has the inferred definition of being a kidney excision with a method of excision and a procedure site direct of left kidney structure. And the important thing to notice here is that when we talk about expressions, we talk about a single clinical idea or single clinical meaning. And we use the compositional grammar as the syntax for representing expressions in a standardized and consistent way. We have the direct link to the compositional grammar specification there. And you can actually see these expressions in the SNOMED CT browser. In the expressions tab, you can see in the bottom, you have the expression for the concept in focus. So where each expression represents a single clinical idea, an expression constraint is a query that is used to identify a set of clinical ideas or clinical meanings. And the expression constraint language builds on the compositional grammar, but it includes a wide range of other symbols, such as the ones you see in this table here. We also have a specification and guide for this language, and you can access it via the URL you see on this slide. The guide includes detailed examples of the features supported by the expression constraint language. Let's look at a few examples of expression constraints, considering the concepts that we looked at before. So this very simple expression constraint retrieves all subtypes of the concept disease, where we use this single less than sign to indicate that we are looking for all subtypes. And because the 2 concepts, malignant tumor of lung and cyst of kidney, are both subtype descendants of the concept disease, they will both satisfy this expression constraint and they would be included in the result set. Another example is the expression constraint retrieving all subtypes of disease that have an associated morphology attribute with a value that is equal to the concept cyst or any subtype of cyst. And out of our three example concepts here, the concept cyst of kidney would be included in the result set because this concept is a subtype of disease and it has an attribute matching the criteria of an associated morphology of cyst or a descendant hereof. Other concepts that would be included as well are concepts such as cyst of stomach, cyst of lung. As shown here, you can see that both of these concepts are types of disorders and they both have an associated morphology of cyst. Another concept that would also satisfy this expression constraint is the concept ganglion cyst of right ankle. As you can see here, the value of the associated morphology attribute for this concept is ganglion cyst, but because this concept is a subtype of cyst, it would also be included because we have specified the attribute value to be either the concept cyst or any descendant hereof. So that was just a bit of background about the expression constraint language, but let's now talk about the evolution of the language, because updates are made when implementation and user requirements are identified. So we are always seeking to make the expression constraint language as useful to implementers. So the expression constraint language have been used in projects and programs around the world for a number of years, and you'll hear more about that in the subsequent presentations. But as you can see here, the first version was released in 2015. Since then, a number of new versions have been published to meet the emerging requirements and use cases. The SNOMED CT browser supports version 2.0, which was released earlier this year. You can always see the version in the brackets here in the expression constraint queries tab of the browser. If we look at some of the more recent versions of the language, starting at 1.5, this was released in 2020 to support description filter constraints. And these constraints filter the result set by matching only on concepts which have a description that satisfies the filter criteria. In this version, descriptions can be filtered based on their term, type, language, acceptability, module, effective time, and active status. So for example, this expression constraint matches all subtypes of heart disease that have a fully specified name containing the word prefix heart. So you can notice how we use the double curly braces to indicate a filter. In 2021, version 1.6 added concept filters, allowing the result set to be filtered based on the definition status, the module, effective time, and active status of each concept. So the expression constraint you see here will match all subtypes of heart disease that have a definition status of primitive. Again, notice how we use the double curly braces for the filter. We have the C to indicate that this is a concept filter. In the example you saw before, we didn't have any letter, but you could also add the D there to indicate that it's a description filter. Then in early 2022, so earlier this year, version 2.0 was published. This version includes a number of significant features, including reference set member filters and the support for returning multiple fields of a reference set. It also includes history supplements to supplement the result with relevant inactive concepts. I will talk more about these two features in a moment. In July 2022, so just recently, version 2.1 was published, allowing description filters to filter results using description identifiers, and also to harmonize the dialects alias filters with the Internet best current practice specification. But now I just want to spend a few minutes exploring the features introduced in version 2.0, because this version introduced some very significant improvements to the language. You may already be familiar with the member of function, and this function evaluates to the set of SNOMED CT concepts that are referenced by the given reference set. So in this example, this example is satisfied by all members of the lateralizable body structure reference set. So this is a useful query because the result will tell us all the SNOMED CT concepts that can be lateralized, where we can apply the laterality attribute. Another example is the members of the SNOMED CT to ICDO simple map reference set. So the result here only includes the SNOMED CT concepts that are included in the map, because by default, only the value of the reference component ID is returned by the member of function. So you wouldn't get any further details about each map record when you just do a member of this map reference set. But in version 2.0, we are now able to return the value of other fields in the reference set too. So for example, you can now specify that you want the values of the reference component ID field and the value of the map target field. So as shown here, this will give you an overview of both the source and the target of the map. And aside from the ability to return different reference set field values, we also have the member filter, providing the ability to filter rows of a reference set based on the value of specific fields. So these filters are specified similar to the other filters with the double curly braces and begin with the letter M. And the example you see here is satisfied by members of the SNOMED CT to ICDO simple map reference set where the map target is C49.1. So you can see the result set will only match on the concept with this value in the map target. And now moving on to history supplements. So version 2.0 is the first version of the expression constraint language that is specifically designed to support querying over historical patient records, which may contain inactive codes. So consider a patient who was diagnosed with a hernia with obstruction back in 2013. And this was recorded using a concept that was active at the time of the recording, but the concept was then inactivated in 2019. Similarly, another patient was diagnosed with a lumbar hernia in 2016, and this concept is still active in the current release. Another patient was then diagnosed with an epigastric hernia with obstruction but no gangrene in 2018, and this concept was also activated or inactivated in 2019. And so on, the same situation for this patient where the recorded concept was inactivated in 2021. So in the situation where a person or organizations wants to perform analytics to identify all patients that have been diagnosed with some kind of abdominal hernia, you could use the expression constraint language to identify all concepts that are a descendant or self of the concept hernia of abdominal cavity. And then you could compare the result of that query to the recorded concepts. However, because the expression constraint language only returned the active concepts within the given substrate, the concepts used in some of the historical records would not be included by this query. Although in a situation like this, it is desired to also include the inactivated concepts in the result, because at the time these concepts were used to record the clinical data, the concepts represented some type of hernia of abdominal cavity. So for this purpose, we have introduced history supplements. So history supplements are specified as other filters using the double curly braces and begin with a plus sign followed by the word history. So you simply add this to the end of the expression constraint, and then you would include all of the inactivated concepts as shown here. I just want to show you how it works. So when SNOMED CT concepts are inactivated, we inactivate all relationships for this concept. You can say it in other words that we literally take the concept out of the SNOMED CT hierarchy so that it's no longer, it doesn't have any subtypes or supertypes or attributes. The concept does retain its identifier and the associated descriptions. And this is why you can still look it up and you can search for the concept, although it is inactive. And as part of the inactivation process, the concept being inactivated is associated with an inactivation or an inactivation reason. So in these examples, the concepts have been inactivated because they were either ambiguous or duplicate. And the inactivation reason then also determines the type of historical association that is established between the inactivated concept and an active replacement. The same as association is used when the semantics represented by the inactivated concept and the active replacement is equivalent, where the possibly equivalent to association is used when the inactivated concept is inherently ambiguous, and there isn't a semantic one-to-one association between the inactive concept and the active replacement. So with the ECL 2.0, we are now able to utilize these established associations between an active concept and an inactive concept to effectively retrieve the intended meaning across historical records. But given the distinct nature of these various historical association types, we have introduced 3 history supplement profiles to support a range of use cases depending on the level of precision and recall required for inactive content. So you can see here how the most restrictive profile, called History Min, only includes inactivated concepts with the same as association to an active concept. So this is useful for safety critical use cases such as the clinical decision support. The History Mod profile includes the associations represented in this set of reference sets, and the History or History Max profile includes all possible historical association reference sets to find any potentially relevant inactive concept. So these profiles are intended to be flexible in terms of the level of precision required. So if we were using the most restrictive profile, so the History Min, this would exclude hernia with obstruction because the historical association for this concept is not supported by this profile. Recall how that was the possibly equivalent to association. And this leads me to the end of this introduction with showing some of the newest features of the expression constraint language. And as said, the browser supports ECL 2.0, so please feel free to go in there and start exploring these new features in more detail. And with that, I would like to hand over to our presenters. And first is Sophie Williams, who will talk about the use of the expression constraint language in research at Barts Health. So hi, Sophie, and welcome. And if you click on the share screen, you can take control.
Okay, thanks, Anne. I'll just get my slides up. Yeah, this one. Hopefully, if I go full screen,
you are.
You'll be able to see full screen.
Now we can. Thank you.
Brilliant. Thank you. So yeah, thanks, Anne, for introducing me. I learned a lot from what you just said, and I can definitely see uses for that kind of history bit that you told us about. It makes one of my slides that I'm going to be telling you about a bit outdated already. So that was really informative. But hi, everyone. I'm here to tell you about how we use expression constraint language in research at Barts Health. And I'm Sophie Williams, and I'm part of the research data science team, which is part of Barts Life Sciences. So I was just going to give you a bit of an introduction to who we are and what we focus on within Barts Life Sciences. And then I wanted to run you through a couple of projects where we do use ECL for research purposes. One is around kind of real-time risk scoring of patients who come into the hospital for certain kind of diseases and complications. And then the second one is around using ECL to identify cohorts of patients, to pick out specific comorbidities and groups of comorbidities, and to pick out symptoms, either from patient health records or using kind of text extraction processes from their free text clinical notes. And then I was going to kind of finish by just talking a bit about the practicalities of how we use ECL within Barts. So first of all, Barts Health. So we are a group of 5 hospitals that provide care for around 2.5 million patients within East London and beyond. So we're part of the NHS. We've got a big cardiovascular centre, cancer centre, a big trauma team, and we're home of the London Air Ambulance. So there's kind of plenty of really high profile research studies going on within the trust, and plenty of opportunities for kind of finding new questions that we want to be able to answer working with our clinical and nursing teams. We've also got one of the largest children's hospitals in the UK, a big dental hospital, leading stroke and renal units. And kind of we've got one electronic health record system that covers all of this. So the data is kind of all linked here. And then as part of Barts Health, we've got Barts Life Sciences, which is a research and innovation program, which is joint between the NHS part of us, Barts Health, and the academic side, which is Queen Mary University of London. So this is all about improving the use of research and getting things deployed within the hospital. And as part of Barts Life Sciences, we've got the data science program, which I'm part of, and this is a team who have expertise in research, development of generalizable tools to analyze data, and the kind of deployment of these tools and models within a hospital environment. And we focus on the questions and the diseases that are really important to our patient population in East London. And we try and make sure that anything we develop can be shared, reused, and deployed. The first project I wanted to run you through was about real-time risk scoring and rare disease diagnosis. And the use case here is about VITT. So this is a really rare thrombotic condition, which was associated with some of the COVID vaccinations. You might have heard about it in the news. So when kind of cases of these started cropping up, obviously the national teams were very keen to better understand who was most at risk of it, how common it was, where these patients coming from. But they realized that in the national data feeds, they just didn't have the kind of granular information they needed to be able to diagnose, like pick up these VIT cases. And the timeliness of data feeds to the national teams is kind of on a monthly timescale, which was far too slow for within a kind of public health real-time emerging disease where they want to get much more information. So a few kind of more local teams looked into whether we can use clinical standard definitions of VITT to both identify patients who've come into our hospital that have had VIT, whether we can pick those out from the health records, and whether we can continue to run an algorithm to be able to pick up new cases that might be coming into the hospital so we can get them seen by the hematology teams if they were currently not being seen by the right team, and get the kind of care that they required. So as part of this, one of the kind of diagnostic criteria is any patient who comes into the hospital with a thrombosis. So to pick out this, we needed to use ECL to scan through any of the SNOMED coded lists to identify patients who fit the criteria of interest. We found that ECL is more inclusive and faster than doing a kind of classical string search on thrombosis. It's really useful as it's always up to date with the latest terminology. For example, over the last few years, there's been kind of new concepts that have been added to the SNOMED terminology because either there's been new procedures, so new vaccinations that we needed to be able to document, and new conditions such as VITT. When we first started the study, there wasn't a SNOMED code for this. So using ECL, once it became a code, it would then be picked up. And then we can use the same ECL query to search over any SNOMED coded data sets and kind of share our search terms with the other colleagues who are doing the same research in different sites. So for example, if you just kind of search in the box thrombosis, you can see things like a family history of thrombosis would come up as a potential match. And obviously this does have the term thrombosis in, but that wouldn't be something that's of interest to this study because we're looking for acute cases of thrombosis, similar with history of thrombosis. So it's just not going to kind of find the right terms for us. So if we look at the relationships that thrombosis has, you can see it's a disorder of the cardiovascular system. It has a finding site attributed to it, which is a structure of the cardiovascular system, and it's got an associated morphology of a thrombus. So kind of looking at the logic of this thrombosis, we can talk to the clinical teams and say, is this kind of precise enough for the kind of patients we want to be picking out as having thrombosis? Are there any kind of tweaks or filters that you'd want to make it more precise about which thrombosis cases we're picking up? And this helps us to kind of refine the ECL we write. And we can review the code list that's produced with this ECL query and refine it as required. So for example, one of the subtypes of thrombosis we're really interested in is deep vein thrombosis. And then we might say we're only interested in acute deep vein thrombosis because this is kind of a complication of a situation that we're interested in. So we wouldn't be interested in chronic DVTs in this use case. So then we can take the relationships from thrombosis and filter them to fit this new use case we're interested in. So here we're saying we're interested in anything that has the associated morphology of a thrombus as a kind of starting point. And then we might want to refine it and say, also it needs to have a finding site of the structure of a deep vein or any child term of that. And then finally, we would say, also we want the clinical course to be sudden onset or short duration because it's acute DVT we're interested in. And this takes us from an option of around 500 different SNOMED concepts that were being picked up with thrombosis to just 31. And again, here you can see in the concepts that if you just search for acute deep vein thrombosis, some of these would be picked up. But then, for example, acute ischemias due to a thrombosis wouldn't have been picked up by string search. So it's a lot more precise. In the second project I wanted to tell you about is around kind of more looking at retrospective data and seeing if we can map any code that's been added to the health record to categories for us to identify patients of interest or to find kind of groups of comorbidities. And this can be used for doing epidemiological research and for kind of risk scoring based on how many different types of comorbidities they have. And this is kind of a generic type of use of ECL that's used in different specific case studies. So, sorry, again, another COVID example. During COVID, we produced a kind of generic data set that could be used for clinical trials. It could be shared with approved researchers, and it was standardized so that everyone had access to the same data set. And as part of that, we had kind of a checkbox. Did each patient have any of the specific previous medical history, symptoms, or comorbidities? And as well as the ECL being able to pick up the new terms that have been added to SNOMED, it allowed for reproducible analysis. So any researcher could know exactly what codes would be categorized as, for example, having asthma. So they'd know whether that category of asthma is relevant to their study or not. And I think we had about 50 or 60 different categories that were all defined using ECL. So when we first started, I was downloading from the TRUD website the SNOMED mapping lists so that I could map all of the new concepts to the historical information, whereas Anne, now you've helpfully said that the newest version of ECL, you can just add in the history term, and that's immediately going to be added to all my SNOMED queries so that we can look at the historical terms, because, for example, we don't know when a concept's been inactivated. So we always want to be looking at historical terms, I think, unless I guess it's been inactivated for a very specific purpose. And another good thing about this kind of comorbidity mapping is that we can also use ECL to refine our resulting code sets to particular SNOMED subtypes. For example, we might want to check which terms that are thrombosis or an asthma would be found in the emergency care data set, which is a subset of the SNOMED that's used in our EDs within England, because we want to know whether it's possible that a patient would have actually been coded with that code, because there's no point searching for a code if no one would have been coded with it. So that it's useful for kind of checking things like that. And then finally, just wanted to tell you about how we use ECL. So as well as the kind of SNOMED browser has a way of building your own ECL queries, we also use Shrimp by Onto Server, Csiro. And NHS Digital have procured our own version of Onto server as our national terminology server. So that can be used to kind of run ECL queries against the API. And then there's some really useful references both from SNOMED and Csiro about help with writing ECL queries. And I'm sure I need to kind of go back to them to see all the updates and the new features that are around. But all of these resources are really useful for kind of getting up to grips with what is the slickest way of writing your ECL query, because quite often I start with like a really bulky, chunky one and then can realize that I can kind of write it in a clever way. So thank you. And yeah, if you have any questions, please let me know. That's all from me.
Thank you very much, Sophie, for your presentation. That was excellent and very interesting. I hope the attendees will ask questions, and you can see them in the Q&A during the next set of presentations. I would just like to hand over to Michael to give his presentation, which is entitled Querying SNOMED CT for 10 years.
So, share my screen. And hopefully you're seeing the title page there. So thank you very much. And I titled this Querying SNOMED CT for 10 years, which is really a shout out to the history of ECL, which I'll touch on in a couple of slides. First, I just wanted to sort of touch on the context of where this is coming from. You may know me from my work with Onto server. Onto server is our Ips Terminology server. Sophie mentioned it in her talk. One of the key things that Onto server support is deep support for SNOMED CT, including ECL. So we've been supporting ECL since before it was ECL, and up to today. And we have one of the, I believe, most performant ECL implementations available, and it allows us to do some very useful things. So getting to the background here, the work on Onto server extends back more than 10 years. So there's a lot of history gone into it. But back in the very early days, nearly 10 years ago, there was a proposal for a SNOMED query language, which looked a bit like this. So it had sort of these keywords with brackets, and you built up expressions by nesting things together. And you can see, you can get an idea of some of the features here. So you've got intersection, you can check whether something's fully defined, whether it matches a particular description, whether it belongs to a reference set. You can get the children of a concept or an expression. You can match on attributes. And so that was kind of the initial proposal. That was the first thing that was floated, and then we got ECL, which was where the syntax was influenced by the post-coordination syntax, and it was not an English language oriented syntax. It's a little bit cryptic, but once we get the hang of it, it's actually, I think, fairly intuitive and really quite compact and powerful. So over the years, this experience was with the use of ECL in Onto server, we've been able to see the sorts of things that people generally use it for, and in particular what we use it for internally, and to sort of understand where we really get the key core value from things. And really there's three main features that people use. It lets you query the hierarchy really easily. That's the number one feature. And it means if you've got an engine that does ECL, you don't need to bother with things like transitive closure tables and all those sorts of details. You can just say, I want all the descendants of this concept, or I want the immediate children. It lets you query the attributes of a concept. So that gives you slightly deeper into relationships. But the other key thing that we see is that because of the dot syntax, which allows you to say, not I want to match this concept, but I want the value of this attribute. And the fact that you can link those together so you can have a sequence of attribute names. It allows you to navigate through the relationship. And this is something that's not easy to do. And, if you're writing SQL, you have to write series of joins, but it's not something that's readily doable with many other terminology. And it's the sort of thing that you end up wanting to do a lot when you're working with terminology involving, for example, medicine, because you're interested in, you're often interested in the substance in a product. And so you may need to go from a product concept to the things that comprise that product, so the tablets in the product, and then down to the substances in the tablet. So this ability to navigate across the relationships is a really valuable element of the language. More recent additions to the language, the ability to query descriptions and the ability to query additional attributes, so things like the module ID and so forth. They give you really handy features for mostly for QA. So if you're trying to understand why certain concepts are included or not included in your query, then these are very handy features. So if you're trying to build up an expression, for example, to find chronic diseases, you might look at the modeling to get all the chronic diseases. But then if you query the descriptions and say, well, what are all the concepts that mention the word chronic in them, you'll find that there are a number that mention chronic that have no modeling to indicate that element of their nature. There's a really handy feature to manage the fact that not all parts of all of SNOMED are modeled to the kind of detail that you might want for some of your queries. And interesting that a couple of these, the ability to query descriptions is actually really only a fairly recent addition to ECL, and yet it was one of the incumbent features in the early draft of ECL. So it took a while for the language to evolve beyond just querying essentially relationships to being able to query other parts of the data. One of the things that is very valuable is the mixture of ECL and FHIR, and there's two parts where that happens. One is the notion of implicit value set, so it means that any ECL expression can be used and expanded or evaluated directly using the FHIR API. You don't have to create any new things on a terminology server. You can make a request directly. The other thing is that you can put an ECL expression into a value set definition. Value sets are very useful in this context for carrying extra metadata. But also you can put multiple ECL expressions into a value set definition, and I'll mention why that's particularly useful in the next slide. And if you have used the print browser, you'll see that we have also implemented an ECL authoring tool. So this is the authoring tool. It's a subset of current ECL at the moment. It gives you an easy way of doing the hard thing, which is finding which is putting the concepts into the ECL expression. So I can quickly search for appendicitis, and I get my appendicitis match for that ECL expression. I can make it an all descendants of appendicitis, and you see I've got 33 matches there. And maybe I want to add one of the history filters in, and so now I've got those 4 retired or same as concepts from the history filter. And you see we're doing dynamic evaluation. These calls are directly to the terminology server. We get really fast response. If I want to do some refinements, I can add, say, a relationship constraint, and I might want to constrain this to the finding site where we have, maybe we want more than one finding site. Who knows? So there we go. We've got 12 appendicitis descendants that have more than one finding site in their model. And there's nothing like this kind of capability with other large terminologies like RxNorm, Loink, and ICD-11, all of which would benefit greatly for something like this. So I mentioned before the ability to put multiple ECL expressions into a value set definition. Why this is really interesting is because of the notion of a substrate. And so the substrate for ECL is actually the data, the set of concepts, relationships, descriptions, and reference sets that are used when evaluating the expression. And they essentially correspond to a version of SNOMED. Because you can put multiple expressions into a value set definition and each one can reference a different version of SNOMED, this allows you to do things like evaluate an expression against 2 different versions of the same edition to see what matches now that didn't match before, or across 2 different editions. So you can see, well, what are the things that match this expression in the Australian release that are additional to the things that match in the international release. So I'd like to do sort of a focused understanding of what the changes are, without having to worry about module IDs and so on. I've just added this extra slide in quickly to answer one of the questions that came up in the chat, which is about doing analytics with ECL and how you might go about that. The way we see it is there's really two key options here. One is that you evaluate your ECL expression locally, or in a terminology server like Snowstorm or on a server, and you get the set of results, the set of matching concepts, and then you take that to your data, so to your database, probably in a temporary table, and then do your SQL query or your joining in the database. That may, and if you're doing lots of variations of your ECL expression, so you're doing sort of dynamic querying, and there are large matches, then that's maybe a lot of data going backwards and forwards. It may not be particularly efficient. The other option is to create a value set with the set of unique codes from your data and store that in your terminology server. And then you can do your ECL evaluation and your joining in the terminology server and get back just the intersection of those 2 sets, which will be much smaller. And so you've got a lot less data being transferred backwards and forwards. And then you bring that smaller set back and do the join with the data in your database. So those are the two key options I see there for the analytics question. Now, I was going to walk through this example in detail. I'm not going to walk through this example in detail. This is one that someone who attended a Connectathon with us came up with. It was in a prescribing context. They wanted to be able to, given a particular product, so in AMT terms, a container trade product pack. So yeah, like a bottle of Panadol of a particular strength, bottle of tablets of Panadol of a particular strength, offer a set of alternate brands at the point of dispense. And so to do this, you have to sort of navigate through the ISO hierarchy of AMT and across various relationships to find the different brands, the alternate brands or the trade products here that contain the same set of ingredients. And so what we did was we walked through how to go from the container trade product to find the trade product or the brands, constraining that to having just the set of substances of the original thing. And so if you follow this link, and it will be available in the slides that are shared after this session, you'll get a little interactive demo of searching for a product and getting back the corresponding alternate brands. But it also, this contains a step-by-step walkthrough of constructing the quite sophisticated piece of ECL, although each little step is an understandable step. So it's a really useful example of how to start small and build up step-by-step a powerful expression that can answer that question in one evaluation. And I've mentioned this already, caveats, relying on the ECL referencing attributes effectively relies on stable modeling, and if the modeling changes, then your ECL expressions are going to need maintenance, and the modeling may not always be accurate or more significantly and commonly not complete. Hence, you need to be careful about checking that you're actually getting back all of the things that you think you should be getting back. And that is the end.
Thank you very much, Michael. And also thank you for your questions in the Q&A and to those helping to answer the questions. Thank you. I will hand over to our next presenter, who is Matt Cordell from Csiro. Would you please take over the screen and start your presentation? And Charles, I can just say that we have seen your hand. We'll take the questions at the end. So I hope that's okay. Matt, you are muted.
Thanks. Sorry about that. I must have double clicked it. So yeah, this is, I guess, a good follow on from Michael's presentation, and it wasn't really intentional, but probably could say it is. We both work together quite closely. And so, yeah, I've probably had 10 years experience using ECL as well. With some of these, I sort of thought ECL was that old and realized it had only come in 2015, but we had a little bit of experience with using some of the proto versions of it. And so I just want to go through some of the good, the bad, and the ugly and lessons learned of using ECL over that time. So first, Michael's already touched on most of these, I think, of how we use ECL, and I say we in the sense of Australia in general. So my first encounter with it was using author error reference sets for the national extension. We had a very early form of ECL in that to create intentional reference sets. And that was things like simple things like we've got a reference set that is all the subtypes of procedure. It was an easy way for people to identify the procedures in the absence of a query language. I guess that's why that we published that. But in general, like value sets, especially within FHIR, it's where it really becomes useful. And I've got at the bottom here that I think years ago, I remember doing a presentation where I said that the introduction of ECL was a game changer, I think, for implementing SNOMED. It really did a lot of powerful stuff, but combining it with FHIR, like that really together, that's a great pair. And doing value set expansions for ECL lets you do a lot of things on the fly without having to code up tables and reference sets and all these sort of things in advance. And maintenance is easier. And so, yeah, the things we use that for are user interface fields, bindings for the information models, mapping context constraints, and data analytics as well, which Sophie touched on how they're using it. So, and quality analysis. So it's a useful way too to share queries. If you find some quality issues, I know in discussions I've had with SNOMED International, it's easier to hand over a query for someone else to interrogate on their system rather than explain in a bunch of language what you're trying to do and what the issue might be. So I'll go through some of the goods and the bads. But in general, I really like ECL and FHIR. So using it for intentional reference sets and value set definitions. These are really one and the same, with reference set being the RF2 form of how you publish these tables, but value sets are a lot more fun. So a useful one we've got at the moment in Australia, all of our jurisdictions have, well, most of them, all of them eventually, will have a list of reportable drugs. And these are drugs that any dispensing of that drug has to be reported to a central authority for monitoring and tracking. Usually it's the serious things that can be abused and sold on the black market. And so to maintain this reference set, all we need to know is the list of ingredients that want to be tracked. So in this example here, I just want to create a set. I just want to look for products that contain fentanyl, codeine, and pseudoephedrine. And to do that, I've got an ECL down the bottom here where I've said I want to track all the medicinal products that contain fentanyl, codeine, or pseudoephedrine, or any substances that are modifications of those three. And that gives us a big set. Again, this query is against the international release. We get over 200 products for that. And that's fine then to use for our reportable drug value set. And maintenance for that is low and easy. We don't actually have to do anything to get new products. They automatically come into the value set as soon as they're added. The only maintenance is if a jurisdiction wants to add a new reportable drug, we just have to add that in. So if someone wants to start tracking morphine or cannabinoids, we add those into the little all queries there, and that's it. Dynamic value sets for user interfaces. This is a really neat one too. You can do, as Michael said, have a whole user interface with ECL expressions, but one of the things I like is using a parameterized ECL. So this example here, that selected isn't part of the ECL language, but if you've got a string with that sort of token, you can take a value called live from an interface and do a insert that into this parameterized string and use those results as well. So an example might be if we've got a prescribing system and the user's just searched up and they've said, oh, they're going to select, say, amoxicillin and clavulanic acid product. They select that and they're not sure what dose forms are available. You can take that concept ID insert it into the ECL query, and then you get another expansion here that will show you the available dose forms that are available for that product. So here we've got a chewable tablet, oral suspension, and just a regular oral tablet. And there's, I guess, how you use this is there's a whole range of approaches, and there's a link here to the SNOMED International's UI examples, and that's got a bit of ECL and expansions in the background there. Content changes can have negative effects too. So this is, I guess, a really simple example, but it was a really wake-up call, I guess, when we had our intentional reference sets published in SNOMED CT AU. And that was this was just what was the definition for our microorganism reference set. So in 2019, we had about 20,000 concepts in that reference set. And then overnight, we did an update and to the latest international release, and we had 0 concepts in that reference set. So in retrospect, it's pretty obvious what went wrong, but this was, I guess, early days, and we weren't really expecting it. But the concept was retired. So in this case, it's an inactive concept, so it has no subtypes to return. But that's still completely valid ECL syntax. So none of the ECL parsers are going to throw up any errors for that. So how to get around this since? We implemented some robust, I'll say they're robust, but they can always be improved, quality systems. So at a minimum, you should be checking ECL components to make sure that all the components are active. Unless you're doing historical queries, there's not much use in looking at inactive concepts within an ECL query. And then the other one that we've got, because I haven't thought of anything better at the moment, was to monitor the changes and determining looking at query over a number of releases and seeing what's a reasonable amount of change, because concepts are added and removed. That's a completely natural thing for SNOMED. And setting a threshold. And often, depending on the size of the reference set and what the content is, 5% might be a good number. And so if there's more than 5% change up or down, you need to have a look at it. And that's not necessarily always bad, but it's good to have systems in place to monitor these things. Another big one is if there's a concept model overhaul. So here we've got 3 different, this came from someone who was doing some analytics a little while back on traumatic injuries and wounds. So you can see here that first query I've got is just for traumatic injuries. And there's a little bit of difference between those 2 numbers between January and July. I'll just say that's down to natural growth of or changes in the terminology. But when you look at the next 2 queries, theoretically, they would be returning the same thing. We're looking at types of wounds and excluding all the traumatic injuries. But you can see this first one, we get nothing in it, both July and January. But then the other one where we do a slightly more elaborate query, the difference between those are 43 results and 425, and that's a pretty marked difference. So what's going on for these? Really all comes down to the morphology hierarchy. You can see it just looking at the traumatic injury concept. The model of traumatic injuries changed in that period from, I guess, overloaded morphologies to being conditions that were due to a traumatic event. But again, both concepts are active, so that's not going to detect in your if you're looking for inactive concepts. And the wound concepts, both of those exist too. So yeah, just this bottom row shows you that the morphological hierarchy, that changed a bit. So again, this is, I guess, just another example of why it's useful to monitor the changes in your queries over time to detect if anything happened that you need to action between releases. Concrete domains was something that I think it's been queryable. We've had access in Australia for a little while with AMT and concrete domains, and it's just become available in the international drug extension. But that's the only place it's used at the moment, but I guess in the future it could be used further. But medicines is the key place for this at the moment. So it's really useful for doing queries, things like, and I've tried to simplify some of these expressions just to make them more readable. These aren't production quality, but they do the job. So this one here, if we want to do products with at least 5 milligrams of codeine, we can do a query like this where we use the greater than equal sign to say at least 5 milligrams, or actually 5 milligrams per mil in this example here, which will be important as we go on. And you can see this query returns, I get two concepts. I get a 5 milligram solution and I get a 60 milligram per mil solution as well. You can also do the less than, but this is where it gets a bit messy. You've really got to understand the concept model and be aware that things are not necessarily always as consistent as you might expect. So here I'm looking for products with less than 5 milligrams per mil of codeine. I've got 3 milligrams per mil. That's correct. It's less than 5 milligrams. But there's also this other concept that's 600 micrograms per mil. That's less than as well. So in this case, there's a couple of different units of measure being used for these concepts. You need to be aware of that and write the queries appropriately so to recognize, take advantage of all the units that are there. Also make sure you really understand the drug model. This is just a simple example where we've got two concepts that are effectively the same, except one's a tablet and one's a capsule. If you're doing strength comparisons here and you're doing a really robust query that does use the denominator unit, you need to use something like a unit of presentation, because the denominator unit is going to be different for each of these. So previous one, the denominator was mils, but this one, they're slightly different. So you've got to understand how that works. And finally, term filters, which is something I haven't used as much. And I guess that'll become apparent as I go through some of the downside of it later on, but it is still really useful. So I think term filters are really useful. I find them useful as a handy shortcut, particularly if you're just doing investigative analytics, exploratory analytics, and you don't want to write a huge query like this one down the bottom here. If I just want to look for ibuprofen tablet, I can just do term tablet because I know that the products are going to mention tablet somewhere in their description, which is a lot easier than saying subtypes of ibuprofen that have a dose form that has a dose form that has a basic dose form that's some type of tablet. Yeah, you might want to do that in production, but it's a nice shortcut. With those two, probably if you're doing that in production, you want to check that you're getting the same results through the query. It's also really useful for targeting detail that's never going to be modeled, or at least isn't modeled at the moment. And so an example might be like the organic brain diseases, so things like dementia and Alzheimer's that are really hard to model in the current concept model. If you know that the things that you're interested in are going to have the words dementia or Alzheimer's in them, this is a really useful way to get those in. And you probably want to use, I think the earlier presentations had like the combination of an elaborate concept model query and putting some term filters in there to help tune it a little bit. It's kind of a nice balance there. So I find the model queries are a lot more reliable and robust, but the terms are really good for just fine tuning where there's just some detail you can't access with the model. Things to be aware of is that term filters, the experience can be variable. So both at a point in time, so this first example here, if I just do a query for subtypes of disease using the term filter of NOF fracture, which is supposedly a common abbreviation for neck of femur fracture, it does match a result. You get one result back, but there's a whole bunch of subtypes that are also neck of femur fractures. It won't return any of those. But also it can change over time. So this example, when I went to pull together these numbers for the presentation, I think a lot of this isn't as stark as what it was more years ago, before 2019. But there's still a difference between these three queries are really looking for the same thing. I'm looking for first degree burn or burn erythema. It's all the same thing. And you can see the numbers here. They're different with each query, and they're different between releases. The difference between releases is consistent for the first kind of. The numbers are a few new concepts added, but you can see within a release, you do get slightly different results. The other thing before I just go on to the last slide was that I guess term filters are only limited to a specific extension as well. Though obviously English terms aren't going to be applicable to foreign language terms or foreign to English, but even within English, queries written for the Australian extension might return different results in the UK, New Zealand, US, and so on. So it's, I guess, yeah, not just language dependent, but extension dependent, edition dependent. So just in summary, to finish up, I'll say ECL is really good. Definitely, it's a really valuable thing to get your head around. But it's important to make sure you understand the content and the models and build some mechanisms in to detect changes, and test and test a bit more just to make sure it's all behaving exactly how you want. Have test cases of results you expect. And just as final word, because I didn't mention extensional reference sets, but it works nicely. So I think ECL is good for things where you can define a set of logical rules for your value set, but for things where it's kind of an arbitrary set of things, extensional reference sets are good. And I think the example for that might be prescribable drugs. That's based on some business rules, not model logic. And that's all. Thank you very much.
Thank you very much, Matt. And yes, and then if you have those extensional ref sets, you can then use ECL to query over the content within them. So in that way, it goes hand in hand too.
Yeah, no, it works really well together.
Yeah, thank you. So the last presentation for today is my colleague Alejandro Lopez Osornio. Would you please take over the screen?
Thank you very much. And yes, we also use the ECL inside the SNOMED International project. So in this case, we would like to show you how the ECL is being used to facilitate the implementation and the guidance over the use of the IPS International Patient Summary. So let me see the next one here. So the International Patient Summary has been described as it's a minimal and non-exhaustive set of clinical data for patients, special diagnostic, condition independent, and is readily usable for all clinicians and schedule cross-border patient care. So it's a collection of information of structured data to create an electronic document that will communicate information about the patient with a summary of the health of the patient. It will communicate what medications the patient is taking, the allergies, the problems, immunizations, the results, the procedures. And this information is like the most concise, important information that the clinician can have at his hand in order to make reasonable care of the patient. It will be very useful to have this information when you have a patient in front of you that you don't know. So the IPS project is a project that is part of different organizations that are sponsoring this project, like ISO, like SNOMED International, HL7, IHE, and these organizations are all working together to create a standard that will allow different countries, different systems, different regions to share structured information in this way. And SNOMED CT is in the core of this, being a terminology that has the coverage to cover all these things that we mentioned, like diagnosis, procedures, medications. There are too many things, and there are really few other options to cover all that. So SNOMED CT is in the core of IPS, and the implementation guide tries to explain how to use IPS in SNOMED CT. But then when you're using SNOMED CT, we have different situations. Yes, you may be in a country that has a national extension of SNOMED CT, and has added content over the international edition. It's a large set of concepts. Then maybe you have a country that doesn't have a national extension. It's a member of SNOMED International, and you have access to the international edition as it's published every month. But if you're outside the member countries or their affiliates, the idea was, because the IPS is something that should be international, global, and cross-border, there should be some content that is available to users that don't have any license for SNOMED. And that's the old IPS ref set. Yes, the IPS ref set is completely free and people can use it. The GPS ref set is something that is in the middle because it includes some other components that are outside the scope of IPS. But for IPS, the main one is the IPS ref set. And the IPS ref set that was shared with countries or with users that didn't have a license or didn't live in a member country was a list, was a plain list of concepts that they can insert into their systems in order to generate and understand IPS documents. And the problem is that the lists are very limited in what you can do with a list. For example, you cannot run ECL with a list. Yeah. So to overcome that issue and to bring the power of ECL to everyone, even the persons who don't have a license, SNOMED International has been working in the preparation and release of the IPS terminology. The IPS terminology is an evolution over the old IPS ref set. It has ancestors, groupers, attribute values. It creates a full ontology using as a seed, as the original part, the IPS ref set. Yes. And the idea is that the IPS terminology should be compatible with all terminology servers that can load the content of the terminology, just like Snowstorm onto server, the ones that we were describing. And these servers will allow you to run ECL over the IPS terminology, over the small set. Even if you don't have access to the full international edition or you don't have a national extension, you will still be able to use the power of ECL inside that small set that is around 15,000 concepts. Yes. So the IPS terminology is a free alternative to the standard SNOMED CT edition, the international or the extension, but contains all the new advanced features. And the idea is that this IPS terminology will be used in non-member countries. The member countries will use their own extension or the international edition, and that will contain an updated IPS ref set that will be equivalent to the IPS terminology. The IPS terminology is currently in beta. Yes, it's accessible as a browser that you can go and look at this small set of the terminology. But the idea is to release the production version of the IPS terminology by the end of the year. So in implementation of the IPS, we can use ECL to do some things. When you're using the IPS terminology loaded into a compatible terminology server, again, like Snowstorm, like the P2I server, like Onto server, if you have loaded that in those ECL compatible servers, you can do more things and you facilitate your implementation. And the main use cases that we found that can be greatly facilitated by ECL was the terminology binding and the international interoperability support. Yes. So let's go through them, just these two cases. So for the terminology bindings, the IPS implementation guide that is being updated right now, there will be a new version, I think, in a few weeks. The guide will express for a field in the IPS, for example, in the condition field, when you have to put the diagnosis, it will say, okay, the diagnosis can come from SNOMED from this set of concepts. It should be a clinical finding, an event, or a situation with explicit context. And the idea is you will do a fire expand operation over that ECL, and you will do that over whatever version of SNOMED you have. If you have the international edition and you expand this constraint, this terminology binding, you will get 124,000 hits. But if you're in the US and you're using the US national edition, you will have a bit more, like 129. If you're in Canada, you get not as much as the US, but more than the international edition, 124.6. And if you're using the IPS terminology, instead of being just a plain list that you cannot filter around, using this ECL, you can identify from the IPS terminology which ones are the ones that are relevant for this terminology binding. And you get almost 7,000 concepts in the IPS terminology that are the result of this constraint. Yeah. So this allows us the existence of the IPS terminology in the same format as all the editions. And using ECL as a common language allows us to create guides that will explain what part of SNOMED is a relevant one, and then you can apply that the same to different editions of SNOMED and get the results that are relevant for you. And also, when all these users want to share information, you may be already thinking, but what happens if I fill my IPS with international edition concepts, and then the receiver doesn't have access to international edition, has access to the Ips terminology, which is a smaller set. So there's a possibility that the sender, using an international edition selection of concepts, might send a concept that is unknown to the receiver. Yeah, the receiver may only have the smaller set. On the other way around is simpler, because the IPS terminology is fully integrated into SNOMED, so everything that is in the IPS terminology is also part of the international edition. So receiving content from in a member country, that's completely safe and fine. But if you send content, it requires some kind of transformation in the middle. And there are some options about how to resolve that, and these options can be supported by the use of ECL. So the best option probably is to send both the local code that I'm using from the international edition, but also attach a second code that is a more general code that is the proximal ancestor in the IPS terminology. It means that it's the closest concept in the hierarchy that is a general version of mine, but is part of the smaller set of the IPS terminology. And the other option is that you can send only your local codes, and the receiver, if he has access to a terminology server that contains the full edition, a public one or whatever, they can do the transform themselves by applying the ECL. Yes, so let's see how that works. Let's say I'm creating an ECL using the international edition, and I have a concept that was entered by a neurologist that says this patient has opercular epilepsy, which is a kind of epilepsy that is related to some specific region of the brain. Yes, and this concept, opercular epilepsy, is not part of the IPS terminology. So what we can do is to create an expression like this one here and execute a fire expand operation over that expression that says, first, give me all the ancestors of opercular epilepsy, because I cannot, this concept is not enough to share, because I would like to have a more general concept, an ancestor that is part of the IPS terminology. So give me all the ancestors that are part of the IPS terminology. That will give me a large set. It will give me maybe 20 concepts that are ancestors of opercular epilepsy. Then I ask them to remove from the results, using the minus, remove all the ancestors of those concepts. So I only get the last line, the line that is just a direct ancestor of opercular epilepsy, and is part of the IPS ref set. It can be some concepts in the middle that are ignored, but it's the leaf from the IPS terminology that is an ancestor of the localization of this concept, opercular epilepsy. And if you do this ECL, what you get is localization-related epilepsy, which is part of the IPS terminology, is understandable by everyone around the world, and it's the same, it's a similar meaning. It's a more general meaning. I don't have the detail about which part of the brain it is, but I know it's an epilepsy related to some part of the brain. In some cases, it's possible that you get more than one concept using this technique. In that case, you will have to resolve which one you pick, maybe based on frequency and some other attribute you may find. So thank you. This is how we can use ECL to support the implementation of IPS.
There I was. Thank you, Alejandro. I'll just take the screen. So thank you, Sophie, Michael, Matt, and Alejandro for your fantastic presentations and for giving us some insights on your experiences and with the expression constraint language. We had some good questions during the course of the session, and Charles, you also had your hand up, so I'll just see if I can invite you to speak up. 2 seconds. So Charles, can you?
Can you hear me now?
Yes, now we hear you.
Great. To be honest, I mistakenly raised my hand, but anyway, I think it would be, I would like to make a comment really about the work that Sophie has done, to make a sort of broad comment about national adoption, engagement with SNOMED and so on, because I think Sophie and I have learned a lot in the UK. So I'm just going to fill in a little bit of what, maybe a little bit more background about that VIT study. It was promoted, and we were asked to do the study by HDR UK, which is Health Data Research UK, which is a national body supporting medical research in England, well, actually in the whole of the UK, and all sorts of people participate in that organization. So individual trusts can be members of HDR UK, and individual people can be members. And essentially the question that was put to us was, we think it must be possible to identify patients with something like VITT, a rare complication of a disease, much faster at a national level than is currently being done by using the normal reporting lines, using uploading of ICD-10 coding and hospital activity, which takes months to do. So the question was, could we find signals of illness much, much earlier than normal? And that if we could, then that probably has a generalizable benefit for healthcare analytics and for the provision of care to a whole population. So I'm a sort of strong believer in the idea. And I think the simple answer, which you didn't see in Sophie's presentation, is that at Barts Health, we could do it using a combination of SNOMED encoding in using the emergency care data set, the problem list, and crucially, the laboratory data associated with that complication. But what we discovered with our collaborators in HDR UK is that other trusts, even using the same software as we do in our underlying EHR is Cerner Millennium, that there are two issues. One is the deployment of SNOMED CT as a terminology within EHRs, and that's not universal in the UK at all. And then the subsequent problem is adoption of SNOMED terminology problem listing within an EHR that does have SNOMED CT deployed. And so I guess my sort of open-ended question to all of you is, we're still miles away from being able to run these kind of queries using ECL at a population level in whole countries. And I think the brilliant expositions that you've all made are fab, but there is now, I think, an increasing urgency for us to say, we've got to get this message out to coders, to doctors, to nurses, that using a terminology and the things that come out of it produces amazing benefits for human beings. And I just thought, yeah, is there anybody out there in this group or further that can do that with us and to get, you know, comprehension of what's behind ECL and the way you can use it? Because I think we're really, we're treading water so much. Anyway, sorry to be rather long and complicated, but I do think we have an issue here.
So thank you, Charles. And well, I certainly understand your question, that what we see right now is very much at a micro level, because what you're talking about is the national data analytics. So maybe we have been in a process of developing the engine, And now it's about having implementations where we can actually collate all of the data so that we can start performing analytics. So I don't know, he's reaching out to all attendees here. Do anyone have a thought or comment to Charles' questions?
I'll make one further comment, and which I think is really helpful. In our work with HDR UK, we're publishing a report on the work that's been done. And the first recommendation of the report is that all organizations should mandate use of SNOMED CT for this purpose. So I think we've moved things along a little bit in the UK, but I would also say that the National Programme for IT mandated the use of SNOMED 15 years ago. So, progress, we need somehow to really alert people to the potential of these cool things that you've all invented.
I really appreciate that that comment there. Alejandro, I think there was a question for you. Can we take that now?
Yeah. I'd just like to add to the response to Charles to say, my experience is that we can tell people to use these things as much as we like, but it's not until we get examples like Sophie presented which show you the value, right? So the actual use in context with clinical issues, the penny drops for people and they see, that would help me. Yeah. So I think getting those stories out, aggregating those stories and telling those stories is the way to get that uptake and that buy-in. Yeah.
Yeah, and for replying to Sergio, I was going to type, but I clicked the wrong button, so I will reply verbally. That yes, the ideal situation is that you send both concepts. Yeah, if you don't know who will read your IPS, it will be good if you send the detailed concept and the more general concept at the same time. And that's one of the benefits of using FHIR, that has this flexibility of sending more than one code and things like that. I see Michael nodding. So.
Okay, I think I'll stop it there because there's only 1 minute left. Time goes fast when you have so much fun. So my final remarks today will be a very brief advertisement for the SNOMED CT Expo, which takes place later this month in Lisbon in Portugal. It's also and virtual, so it's a hybrid. So we have multiple streams of content and demonstrations. So please register for Expo going via this site here, snomedexpo.org. Also, the next upcoming web series will be a special session held in conjunction with the SNOMED Expo. And other web series webinars include the quarterly implementation web series. That's the one you're attending today. We have clinical web series and research. So please visit the snomed.org/web series for more information about the next sessions. And finally, if you'd like to join SNOMED International SNOMED implementation community and will be notified about these webinars and other news, then you should visit us at snomed.org/USRG. Scroll down to find the registration form and we'll add you to our group. So with that, thank you very much for attending and thank you for all the presenters for their great presentations today. Thank you very much. Bye.